So if a sample of air occupies 500 milliliters at STP, what is the volume at 85 degrees Celsius and 560 torr? So STP is the standard temperature and pressure. So standard temperature is 273 Kelvin and standard pressure is 1 atmosphere. Now, to solve for V2, we gotta use the combined gas law. So P1 V1 over T1 equals to P2 V2 over T2. So we're gonna do a cross multiply here. So P1 T1 times T2 equals to P2 V2 times T1. And now to isolate V2, we're going to divide by P2 over T1. Now doing this, so this and this and this cancel out. Therefore, V2 equals to P1 V1 T2 divided by P2 times T1. Now P1 is 1 atmosphere, V1 is 500 milliliters, T2 is 358 Kelvin, P2 is 0.74 atmosphere, and T1 is 273 K. Now atmosphere and atmosphere cancel out, Kelvin and Kelvin cancel out, so we end up with only the unit of volume. That tells me that my setup is correct. And V2 is 886 milliliters. So let's do one more example for combined gas law. A sample of oxygen gas occupies 500 milliliters. So V1 is 500 milliliters at 722 torr. So P1 is 722 torr and minus 25 degrees Celsius. So T1 now we want to calculate the temperature. So we want to know T2 and we want it to be in degrees Celsius. If the gas has a volume of 253 liters, so V2 is 253 liters and P2 is 491 millimeters of mercury. So I'm going to convert the pressures to make sure that we have the same pressure. So each 760 torr is 760 millimeters of mercury. Therefore, this is going to be also 491 torr. Now we're going to use combined gas law. P1 V1 over T1 equals to P2 V2 over T2. To solve for T2, we're going to cross multiply first. So P1 V1 times T2 equals to P2 V2 times T1. And to isolate T2, I'm going to divide by P1 V1. So T2 equals to P2 times V2 times T1 divided by P1 times V1. Now P2 is 491 torr. V2 is 2.53 liters. And T1 is 248 Kelvin. P1 is 722 torr. And V1 is 500 milliliters. The volumes don't have the same unit. We gotta make sure that the volumes also have the same units on both sides. So each liter is 1000 milliliters. And now torr and torr cancel out, liter and liter cancel out. And we're gonna end up with Kelvin, which is a unit of temperature. So the answer is 853 Kelvin. Now we want the temperature in Celsius. Remember that the temperature in Kelvin equals to the temperature in Celsius plus 273. Now 853 equals to the temperature in Celsius plus 273. Therefore, your temperature in Celsius is 580. Now, let's look at sample of gases. So if we have a mixture of gases, how do we find pressure, temperature, and volume of a mixture of gases? So remember that the volume of gas is the volume of container. So even if you have a mixture of gases, the volume of your gas mixture equals to the volume of container. Temperature is going to be the temperature of the entire mixture. However, the total pressure of the gas mixture is the sum of partial pressure of each gas. So if you have a gas mixture that's composed of gas A, B, and C, the total gas pressure is the sum of partial pressure of gas A, gas B, and gas C. Same thing with the air. The pressure of the air, or the atmospheric pressure, is the sum of partial pressure of the gases in the air. Those gases are nitrogen, oxygen, argon, carbon dioxide, and different types of gases. So you need to know the Dalton's law of partial pressure.